This video is about page 7 of your Chapter 8 notes packet. It's lesson 8.4 on using scientific notation. I believe all of you have studied scientific notation before, so the first half is just quickly going over it, and then the second half we'll go ahead and use our exponent rules to simplify problems using scientific notation. Okay, so scientific notation is just a way to write really large or really small numbers that often have lots and lots of zeros in a more manageable way. So an example might be if you were measuring distance to the planets, that's a really large number. Or if you're measuring the size of a bacteria, that's a really small number. The key is the format is always in this format, a times 10 to the nth. Okay, a is a number that's between 1, it can be 1, but less than 10, and it's the absolute value. A could be a negative number. You always use the x for multiplying, the times, and then it's 10 to the nth power. N is an integer. That integer could be positive or negative. Okay, so looking at here, we start with two numbers in standard form, and we want to write them in scientific. These numbers are in standard, and we want to go backwards to, or sorry, these numbers are in scientific, and we're going to write them in standard. Okay, the key is that you just want to make sure that it gets in this format. So I need a to be between 1 inclusive and 10. Okay, currently it isn't. My decimal, if it's not given, is assumed to be on the right. And I'm just going to figure out how many decimal places. It's not how many zeros, but how many decimal places I have to move it in order to get it between 4 and 2, to get 4.2 essentially. Okay, so I've moved it 3, 4, 5, 6, 7 places. So I'm going to write down all the numbers up until the last number that's not a 0, and then I got to use the x for times. I have 10, and I said I moved it 7 places, so that's 10 to the 7th. Okay, that makes sense because this is just 4.259 times 10 to the 7th. What is 10 to the 7th? 10 to the 7th is 10 million. Well, 10 million times 4.259 is going to give you the 42,590,000. Okay. Here, I'm just going to move it this way. Since this is a really small number, it's going to be a negative 1. Go ahead, pause the video, and see if you can get that one right, and then check back. Okay, you should have gotten negative 5.74. It's negative because the original number was negative. Times 10 to the negative 5th. It's a negative exponent because this is a really small number. Remember, 10 to the negative 5th is the same thing as 1 over 10 to the 5th, which is the same thing as 1 100,000ths. Okay, this makes sense because we have the tenths, hundredths, thousands, 10,000ths, 100,000ths. Okay, so again, this is just negative 5.74 times 1 to the 100,000th. And that is going to give us that number. Do remember the negative exponent doesn't mean a negative number. The only reason this is negative is because the original number started as negative. Okay, going the opposite way, now I'm going to move the decimal. I got to make sure I move it 6 places in order to write it in standard form. So I'm going to write it down. I'm going to move it 1, 2, 3, 4. I'm just going to keep moving it. I can put placeholder zeros, and then I'm going to rewrite it because this is very hard to tell what the heck I'm writing. So I have negative 2, 0, 0, 7, 5, 0, 0. I can go ahead and put in my comments. Okay, it's negative 2,007,500. Go ahead and try B, pause the video, and then check back. Okay, did you get 0.000165? It's fine to have a leading 0 if you wish. Just make sure it's very clear where the decimal is. Notice again that I kind of showed my work and then I rewrote it. Okay, so now we're going to evaluate the expressions, and we're going to write our answer in scientific notation. Okay, we want you to use your exponent rules. Do not write these in standard form and then multiply them out on your calculator. That's not what we're trying to do. Okay, we're going to use our exponent rules to evaluate. Okay, no standard form. You will lose points on the test if you write things in standard form when you're asked to evaluate. Okay, so if I think about this, these two numbers are written in scientific notation, but really all this is multiplying. I know because of the associative property multiplication, I can group these in different ways. The commutative property allows me to change order. So I'm going to go ahead and put the numbers first. So I have 8.5 and I have 1.7. I then have my exponents, 10 squared and 10 to the 6. Okay, and I'm multiplying. So now I'm going to do my multiplying. 8.5 times 1.75 is 14.45. So I got that. And then I have same base, and I can add the exponents. 2 plus 6 is 8. Okay, that's not written in scientific notation, so I got to go a step further. First, I'm going to put it in the format with the x. Okay, and then I'm going to notice 14.45 is not between 1 and 10. Okay, so I need to adjust it. There's a couple ways to think of it. One, you can write 14.45 in scientific notation, so that would be 1.445 times 10 to the first, and then I still have that 10 to the 8th, and so it becomes 1.445 times 10 to the 9th. That's my number in scientific notation. If you don't want to kind of write it out here, sort of a trick is 14.45. I want to make that smaller by a tenth. So I'm going to make this larger. So 1.445 is smaller than 14.45. So 10 to the 9th is 1 larger than 10 to the 8th as far as the decimal place. Okay, so that's another way to think of it. Go ahead and try B and C. Be very careful on B, but try them. And pause the video and then check back and make sure you adjust your work if you were incorrect. Okay, looking at B, you should have gotten 2.25 times 10 to the negative 6. Be very careful. You can use your exponent rules and just remember the 1.5 is impacted by the 2. Or you can think of this as something squared is just the one thing multiplied by itself, if that helps you remember. But be very careful that that first number is also impacted. That, when we did the math, ended up in scientific notation, so we didn't have to do anything else. On letter C, this is just numbers, okay, and dividing. So I can take the regular numeric part. 1.2 divided by 1.6 is 0.75. I can use my exponent rules, or I could have used the fact that this was negative to realize that this is going to simplify to 10 to the 7th. Okay, now I have 0.75 times 10 to the 7th. This is not in the proper format. So I can either think about I got to make it 1 larger, so I'm going to make this 1 smaller, or I can think about this written in scientific notation, and then when I do my exponent rules, I end up with 7.5 times 10 to the 6. Okay, make sure you check Canvas. I think there'll be a few additional problems that you need to do for homework. Thank you. This is it for the notes.